and today we are looking at Java solid principles. We want to dive deep into these, understand what they are and what they're used for, and how we can implement them in our real life uh, Java development projects. So, what are solid principles? So, solid basically stands for single responsibility, open close principle, disk of substitution, interface segregation, dependency, inversion. So let's jump right in and see what these entail. So, what are solid principles? It's a set of 5 design principles for object-oriented programming that were introduced by Robert C. Martin, and this was around the year 2000 on one of his papers that he submitted. So, these principles help developers to create more maintainable, highly scalable, and robust software applications. These also include uh, high performance, enhanced testing, um, decoupling, abstraction. So all of these encapsulated in sort of these 5 principles that help us to deliver highly scalable and well managed software code. Now let's see what we have going further. Stick right deep in. So as we've discussed what solid stands for, and let's start with the first one. We are going to single responsibility principle. So this is essentially a what it says is a class should have only one reason to change or only one reason to exist. So in Java, this means each class should have only one responsibility or a job that it's supposed to accomplish or it's supposed to do. So that responsibility is one thing that makes that class to be there and should perform that function really, really well. So this principle helps us keep our classes focused and makes them easier to maintain because they are driven to functionality that they're supposed to deliver, not just there for the sake of being there. So if you want to send notifications, you have a notifications class. If you want to send an email, you use the notification abstraction to send an email and all of these other communications that you want to send. If you want to do a print of a PDF, you use printing class to fulfill that type of responsibility, and that's what it entails there. So in a nutshell, the code looks something like this. Of course, this is a Java Pojo. We encapsulate a person object, which we are saying um, person object should only contain person related details and nothing else. I wanted to keep it simple so that you see what we mean when we say single responsibility. It does only one thing. Like this Pojo that we're looking at, it encapsulates the person details and nothing else. You shouldn't at this point or in this class be sending an email. This is just to get and set the email, and that's it. Nothing else. Just it's a value object and it handles the data in transit, and that's it. So the email sending process should follow the notifications sort of a channel. It should have its own dedicated class with that responsibility to send the email, and that's what we mean by single responsibility. So let's go further and see on the next one. We have open closed principle. So here what we're saying that a class should be open for extension but closed for modification. So because a class has a single responsibility, it shouldn't be modified to do other things. It should only do that one thing, and it can be extended to other classes to aid in them fulfilling their type of functionality or responsibilities. You can extend it to further do other functionalities so that it helps you with what it already has or what it already does. So in Java, this means that classes should be designed in such a way that new functionality can be added. So that's why we extend into a new class to add new functionality from the existing one. So new functionality can be added by creating new classes rather than modifying existing ones. So we don't want to modify an existing class because it has its responsibility and its functionality, and that should not change. It should remain as is unless you are addressing an issue or fixing a bug on that particular class. It shouldn't be touched. So you can extend into a new class that can do the new functionality, and you take it from there. So that's what we mean by open close. So it's open to extend to new functionalities, but it's closed for modifications, and that's what we mean there. So if we look again at our person example here, what we mean is a student is a student is a person, but it's a special type of a person. In terms of an institution, you have every individual that comes in is a person, but they have different roles and responsibilities. So you have special types of persons. So a person can be a student, person can be a teacher, can be a principal, or an employee of the institution, and all of those type of persons that you have within an institution. So with a student, you extend from a person because looking at person details, your first name, last name, and email, and all the other details that you want. And then you're saying for a student, it extends person, which means a student does have, it inherits first name, last name, and email, and then it further goes to have a student number and the course that they enrolled for. So that's a student. Then a professor would be, a professor extends a person, but then they would have like an employee number and uh, um, a major course that maybe they are teaching, and something like that. So you can add more to different types of persons, and that's what we mean here. So class person is open for extension as we are extending person to a student, but it's closed for modification. So that's what we mean by open close. So you can extend the base class to new type of features that you want. For a student will have its own behavior, a professor will have its own behavior, a teacher like something like that. And that's how open close principle is handled there. So going further, we have Liskov substitution principle. So what we're saying here, subtypes should be substitutable for their base types. So this means that a subclass should be able to be used in place of parent class without causing any issues or unexpected behavior. So let's see this in an example so that you see what it means. So here we have a public class square, and it implements an I-shape interface. So we have an I-shape interface here, and we say I-shape just spin. We just want the shape to spin and nothing else. Of course, you can add other functionalities that are in line with the shape, and that's what we mean there. So public class square implements I-shape. So as it implements I-shape, we want to say spin, implement our rotation here. So we'll write our code here to do the rotation for us. So if you look at this line here, we are saying a new square, we are instantiating a new square into a shape data type here, and this should not break anything in your code according to our Liskov substitution principle here. So we're saying the parent class or the subclass can be substitutable. The subclass can be substitutable by the parent class, which is the shape class that we have, and we shouldn't have any issues with this instantiation here. And that's how Liskov helps us to abstract um, the type of instances that we want, or the dependencies that we have from parent to child, or child to parent. We can decouple that in Liskov substitution. That helps us out a lot, actually, and you will see this in dependency invasion later on. So a class square is substitutable with base class iShape. So this allows us to be flexible enough to use the base class to instantiate any child that implements it or extend that particular um, um, base class. So that's what Liskov is. And then going further, we have interface segregation principle, which is a client should not be forced to depend on methods it does not use. So what this means is, if you have an interface and that particular interface does, let's say, two or three methods, it has two or three methods, and you have a class that implements that interface, but it does not do all of those methods, then that class should not depend on that interface. You should segregate that particular interface into two different interfaces, and then implement those interfaces within that particular class where you need it, and only implement the ones that you need for those specific classes and those specific features. That's what it means. So essentially, we want our interfaces to be small and focused as to what they deliver. That also speaks to single responsibility with only the methods that are needed by the implementing classes, and that's the simple of it. And seeing this in an example is, so we have two interfaces on this one. We have iGadget and we have iMobile. So of course iGadget is maybe we have like boot up your gadget, or shut down, or those type of methods here. And then you have iMobile interface, which is a mobile browser, just an example here of what you can have for iMobile. So the different classes that implement these interfaces. So a computer is a gadget, but it's not a mobile, that we know. And also a mobile is a gadget, but it of course it is a mobile. I guess here I should have used like phone or something, but just to show the differences here, that a computer is a gadget and a mobile is a gadget, but a computer is not a mobile, so it cannot implement iMobile. It can only implement gadget, and that's it. So mobile implements iGadget and iMobile, and it can use these two methods that are here to do its functionality there. So class computer is a gadget but not a mobile. So this is what we mean by interface segregation, that do not force a computer to implement a mobile browser when a computer is not a mobile device. That's what we essentially mean by interface segregation. And then we move to the next one, which is dependency invasion principle. So what we're saying here is that high-level modules should not depend on low-level modules. This speaks volumes when it comes to decoupling your code and making it simpler for it to execute. So both should depend on abstractions. So the high-level modules, you should not depend on low-level modules. They both should depend on abstractions. So the decoupling that we're talking about, and this is the abstraction that we're going to see now. So this essentially means that classes should depend on interfaces rather than on concrete implementations. So we want our interfaces to be the ones that gives us the dependency um, for different implementations or responsibilities, instead of concrete implementations classes. So this principle actually, it assists in keeping the code flexible and allows for easier changes and updates, because we are much more free to change the concrete classes, and we won't need to break anything within the dependencies that we have on our implementations. So let's see this in an example. So I have two examples here, a MacBook here, which is a computer, and a Samsung here, which is a mobile or a phone. So we still have our two interfaces here, boot up and mobile. So you can see here a MacBook has iGadget, which is a gadget. So this gadget can come in as a computer. It could be any computer. I just used a MacBook here so that you can see that on iGadget you can pass in like new computer like we had here, or we can pass in new MacBook, which is a computer, and then it will instantiate a computer gadget for us, which is a MacBook, and that would be fine. That's the dependency that we have here, and because we are depending on the interface, we can pass in any type of a computer here. I should actually call this computer and not just MacBook, because a gadget can be a MacBook, can be HP, can be Dell, it can be all those other computer gadgets that we have. You can just pass that, and then because our abstraction we already have that interface, we can pass in that and to implement that, and we are good to go. So I should have renamed this to computer, and then computer will then implement new MacBook, Dell, or whatever computer that I pass in, and it should be good. So on this one we have iGadget and iMobile. Also on Samsung we have a gadget as well and mobile. So on the gadget I can pass in Samsung, or I can pass in iPhone, and then on the mobile front I would want to have a new mobile, which is essentially my iPhone or Samsung, that will then have a mobile browser and the features of what a mobile has. And because we are passing in a new gadget, we won't be having any issues when it comes to putting up our gadget and or starting it up, shutting it down, and all those type of things. Because we're depending on an abstraction, we can boot up any type of a gadget. I guess I should have renamed the classes to something that's much more generic. Like this one should have been the MacBook, should have been a computer, and this one should have been phone, because you can still have a different gadget, which is a watch, and then the different type of watches will start that gadget in that type of a way. But yeah, I hope this sort of makes sense in terms of the interfaces that we have. If we follow these interfaces, we want this type of decoupling of our dependencies here. And so dependencies are based on abstraction, classes, and not on implementation. So we depend on the abstraction, which is our interfaces, instead of implementation classes, which is something like this. So these are the implementation classes, computer and mobile. So here we are depending on the abstraction, which are the interfaces that we have, instead of the implementation. And I would like to say that that's it for this video. I wanted to keep it short and sweet, and I hope that you do remember to like and subscribe. And thanks to you, we're growing stronger, and much more is coming. Keep a watch on the Spring Boot series. There's more coming. See you in the next one. Cheers.